Hello, good morning, everyone. I welcome you to this training in a series of training for environmental impact assessment. And today we are going to look at remote sensing applications in environmental impact assessment. And the particular topic, training topic that in this module we are going to look at is introduction to remote sensing environmental management. Because in order to assess the applications of remote sensing in environmental impact assessment, we have to first of all understand the concept and introduce ourselves to what remote sensing is actually all about and its importance in environmental management. So, in trying to have a background knowledge about the remote sensing is one of the sources of obtaining geographic data which are valuable for mapping, environmental management, and planning. If you can recall ourselves, or if you are familiar with the previous training we have carried out on this platform, we mentioned that remote sensing is one of the sources of acquiring data for a geographic information system. And trying to understand that it's very important and a valuable tool for mapping and environmental management and planning. So let's try to dissect the definition of what remote sensing is actually about. Remote sensing could be described as the science and art of obtaining reliable information about an object, an area, or a phenomenon through the analysis of data acquired by a device that is not in contact with the object, the area, or the phenomenon under investigation. So what this definition actually trying to tell us about remote sensing is that it is a way of acquiring information or data about an object without that device you are using to acquire the data not actually being in contact with the device, the object, or the area you are trying to gather data from. So, in a nutshell, by way of using remote sensing, it means the data you are trying to acquire means you are not in contact with it in any form, any way. As we are progressing, we are going to see the different tools and technology that are used to acquire this information from afar. Also, remote sensing is done by sensing and recording reflected or emitted energy and processing, analyzing, and applying that information. So, in one of the ways or in the process of using remote sensing in trying to study environmental impact assessment, is that this informations that are being obtained from the remote sensing remote sensor is through the process of reflection or emitted energy from the object where the radiation has actually been focused on. And also, the image data that is acquired by remote sensing relates to the electromagnetic properties of the Earth. So, as we are going to go further in this training, we are going to understand that in an electromagnetic spectrum, different objects on the Earth's surface have different reflectances, and there are several wavelengths within the electromagnetic spectrum, whereby objects on the Earth's surface reflect electromagnetic energy that has been emitted from the sun to this object on the Earth's surface. So the electromagnetic properties of this object on the Earth's surface is actually very important in trying to understand how objects could be information or data could be captured from this object on the Earth's surface. So also, remote sensing data can be interpreted and processed without other information. The best results are obtained by linking remote sensing measurements to ground measurements and observation. So what this is trying to explain is that in order for you to actually obtain reliable information from your remote sensing data or system, it should be coupled with, or it should be accompanied with actual ground measurement, what we call ground truthing, whereby you go to the field to actually observe some specific features that you have observed in your satellite imagery or your remote sense data, and try to marry that with what you've observed in order to precisely have reliable information about the object you are trying to observe or get information from. And also, remote sensing provides multi-purpose image data. A data set thus can be of use for more than one organization and can also prove useful for historical studies. So what we are trying to say here is that remote sense data can be used for multiple purposes and depending on the organizations. In our own area of interest, which is environmental impact assessment, the remote sense data that we've actually acquired can be extracted and used to obtain several informations that we can use to manage our environment and try to understand the impact of developmental projects or the impact of certain activities that has been carried out as a result of project on the environment. So depending on the organization that is actually adopting this technology or trying to utilize this technology, it has multiple purpose image data depending on the resolution and the source of the images. So like we are trying to describe before, we talked about the properties on the Earth's surface having different electromagnetic spectrum and trying to give us various data depending on which wavelength or electromagnetic spectrum they actually fall within. So all objects with a certain temperature radiates electromagnetic waves of various wavelengths. Like you can see in the diagram below. The diagram below tries to depict a range of wavelength along the electromagnetic spectrum, and the total range of wavelength is commonly referred to as the electromagnetic spectrum, which extends from the gamma rays to the radio waves. So from the diagram, you can see the list in terms of the range of wavelength is from the gamma rays and extend up to the television and radio wave. So this is a pictorial diagram that tries to describe the range of wavelengths along the electromagnetic spectrum, and different objects on the Earth's surface reflect this electromagnetic energy that has been transmitted to them within this wavelength. And our understanding of this electromagnetic spectrum will actually give us an idea on how to interpret information and data from our remote sensing objects or phenomena we are trying to study. And also, remote sensing operates in several regions of the electromagnetic spectrum, like I've explained before, and the visible portion of the spectrum is commonly called light. And this is the only portion of the spectrum that can be associated with the concept of color. So the concept of color, whereby you have the blue, the green, and the red, which we are familiar with in our studies of physics of the primary and the secondary colors, is within the visible range. This is the range of colors that is actually visible to the human eye, whereby we try to discern colors of objects of different types on the Earth's surface. So this is what we call the visible portion along the electromagnetic spectrum, which is very useful in our understanding or try to interpret imagery from our remote sense data. So as we are progressing, we are going to actually make use of the knowledge of this electromagnetic spectrum in trying to try to understand how to apply this technology in environmental impact assessment. So away from the knowledge we've had about electromagnetic spectrum and the little background knowledge or concept about electromagnetic spectrum, so let's look at the components of a remote sensing. What actually makes up a remote sensing system? Because For you to actually know how the system functions properly, you have to have an idea of components, the different units that actually make up the system. And the basic remote sensing process involves an interaction between incident radiation, maybe from a source such as sunlight, and the target of interest, which is on the Earth's surface, which could be our natural phenomenon, it could be the soil, it could be the vegetation, it could be the water bodies on the Earth's surface, and it's made up of 7 components. So the components that make up a remote sensing system is one, the source of energy, which could be the sun, or in most cases, it's always the sunlight, the radiation and the atmosphere, whereby this radiation, this electromagnetic energy source travels through, and also the interaction with the object on the Earth's surface, whether it is the surface water body environment or the soil or vegetation. These are the objects that this electromagnetic energy interact with when it gets to the Earth's surface, and also the record of energy by the sensor, which is actually the different remote sensing platform, which actually record the electromagnetic energy from objects from the Earth's surface. And we're going to progress. We are going to look at and know what these different sensors represent and how to classify them. And also, another component is the transmission, reception, and processing, whereby all the information that has been recorded by the sensor are being transmitted to base stations on the ground and Earth's surface and received by the scientists or human or individuals that are in charge of receiving this information and processed before they are being sent out for public use in trying to carry out different studies and applying in various sphere of life to understand the impact of project on environment. Also, another component is the interpretation and analysis, whereby after receiving this data, probably a satellite imagery, after downloading your satellite imagery, several analysis and interpretations are being carried out to actually discern the particular information that you are trying to study. For instance, maybe you are trying to look at the vegetation, changes in the vegetation cover over a particular area as a result of the setting of a project. So your interpretation of this satellite imagery that you have received will actually give you knowledge or information that you are trying to discover or trying to find out about the changes in the vegetation cover, and also the application. The application here means the different areas of human endeavor that this technology is actually applied to in trying to solve problems. For instance, in our area, which is environmental management, this is a very important tool which we use to try to manage environmental phenomenon and try to understand the impact of projects on the environment. So we are going to look at these components one after the other and see how they are actually important in environmental management. So the energy source, like I said earlier, is the first requirement for remote sensing. And it has to have an energy, every remote sensing has to have an energy source which illuminates or provides electromagnetic energy to the target of interest. So the requirement is that for a remote sensing to actually work, there will have to be a source of energy which actually radiates or illuminates the object that we are trying to study. And in most cases, the source of energy is the sunlight, which is like a universal source that covers every part of the earth at any point in time, depending on our location on the earth's surface. So this knowledge of this source of energy for remote sensing is very, very important, because you could, as we are going to progress, we are going to discover that there are some remote sensing system or some sensors which you actually use, might want to use to actually study phenomenon on the Earth's surface that does not require source of energy from the sun. So this is a very important component. of this system, which we actually have to understand. And from for the study of the electromagnetic range, wavelength range, the energy that is being transmitted from the sun comes in different wavelengths, and the object on the Earth's surface has the ability to receive or reflect this electromagnetic energy depending on the substance or what they're actually made up of. So, for instance, the reflectance of the electromagnetic energy on the water surface or on a vegetation or on a soil is different, depending on considering the composition in which they are actually made up of. We are going to see how this substance reflects the electromagnetic energy and what is the significance of trying to understand the wavelength in which they emit. So, apart from the energy source, another important component of a remote sensing system is the radiation. And as the energy travels from its source to the target, it comes in contact with and interacts with the atmosphere in which it passes through. So this interaction may take place a second time as the energy travels back to the sensor. So what this statement is trying to explain is that energy from the electromagnetic from the sun travels through the atmosphere, and the process of traveling through the atmosphere, depending on the different objects in terms of like, especially for instance, molecules on the in the Earth's surface, they come in contact with this object on the Earth's surface, and several things could happen in the process whereby there could be the reflection of this electromagnetic radiation. It could be a scattering of this electromagnetic direction in a different direction. There could be absorption of this electromagnetic radiation, and as they get to the objects in which they interact, when the object actually reflects or emits or absorbs some of this electromagnetic radiation, in the process of the radiation going back to the sensor, as you can see in the diagram using the object, the alphabet B, that is where this particular phenomenon takes place, the phenomenon of radiation. Radiation in the process of radiomatic information that comes from the sun and the one that is actually reflected from the object has go through different processes of reflection, absorption, or scattering. So the knowledge of the particular environment, or maybe trying to understand the cloud cover in that area, will give an idea of the quality of information that you can actually get from your remote sensing data. So another component we are going to look at is the interaction with the target. And once the energy makes its way to the target through the atmosphere, it interacts with the target, and depending on the properties of both the target and the radiation, it could actually have various wavelengths within the electromagnetic spectrum that is being sent back to the sensor. So like I said earlier, there are several targets on the Earth's surface which we can actually use remote sensing to study. For instance, we are trying to look at the vegetation cover, how it has changed as a result of a project, or whereby siltation in water bodies, whereby a river that was actually before flowing very well and has a wider width has shrunk in size as a result of emission or washing away of salt and silting the water bodies, reducing the size. So these targets can actually be studied when the electromagnetic radiation from the sun travels through the atmosphere and hits on this object. So the composition of this object, what actually happens thereafter after this radiation targets this object on the Earth's surface, we actually determine what is being sent back to the sensor for recordings. For instance, there are some phenomena on the Earth's surface that has the ability to absorb or reflect back certain wavelengths in the electromagnetic spectrum. Some wavelength within the electromagnetic spectrum. So for instance, when you are trying to study plants or forests, for instance, if you look at the reflectance property of the leaf, it is discovered that the plant vegetation actually absorbs every other wavelength within the electromagnetic spectrum and reflects the infrared. So for you to actually understand the vegetation cover or the area whereby you have vegetation within an area, you have to understand that, have that idea at the back of your mind that vegetation actually reflects infrared. So for you to actually understand, you have to look out for, maybe using your software, try to set your band combination such that the reflectance from the infrared is more pronounced, and this will now give you a color that will actually show you the extent of the vegetation cover within that area. So the interaction of the electromagnetic radiation that has passed through the atmosphere on the target is very important for you to actually understand what is being reflected back to the sensor, because it is what has been reflected or emitted back to the sensor is what we are actually going to see, and trying to understand what you are trying to, information you are trying to get from this object on the Earth surface. So away from that, another important component is the recording of the energy by the sensor. So after the radiation has traveled from the source of the energy, which is the sun, and traveled through the atmosphere and hit the target on the Earth's surface, what happens is that this radiation could be absorbed by the substance or phenomenon or object on the Earth's surface. Some of the radiation could be reflected, and some of the radiation, the object that has absorbed this radiation could also emit its own radiation back, that is now sent back to the sensor. The sensor of various categories could have space-borne sensor in the such like in terms of your aerial photography, whereby you use your drone or your aircraft attached with camera and try to monitor the object or phenomenon, or try to study object or phenomenon on the Earth surface. Those are the airborne sensors. And another sensor could be the space-borne sensor, which are the different satellite images, the observation satellite that we have on the Earth surface. So depending on the type of sensor that is being used, the information that we could actually extract from these sensors can be of help in trying to manage the environment. And also the altitude in which these sensors are being placed on the Earth surface. You cannot, in trying to study the sensors, the altitude of the sensors, just like where you have the aircraft or your drone flying, is not the same altitude where you have your satellite imaging. And also the capability of the sensors also varies depending on what they have been actually built for. So those are the things that you actually have to understand about your sensor for your remote sensing, and how they receive the electromagnetic information that has been sent from the target that you are trying to study to these sensors. So the target could radiate information or reflect the radiation. It could absorb some of them. It could also emit some of them, which now travels back through the atmosphere to this sensor and is being recorded in this sensor for processing when we are trying to gather information about this object on the Earth surface. So another component that is very vital in a remote sensing system is the transmission and processing of the information or data that has been received by the various sensors on the Earth surface that has been placed above the Earth surface. So your satellite imagery or your camera that is airborne, that has been attached to aircraft or your drone, received this information, the radiation that has been reflected by the object, and this information or objects that has been stored in this sensor are being transmitted to base station for processing. So further processing could help to enhancing some of the information that has been received in the raw form from this sensor. So the energy that is recorded by the sensor has to be transmitted, often in electronic form, to the receiving and processing station where the data are processed into an image, whether in hard copy or in digital format. So these data are actually processed. For instance, you are trying to acquire a satellite image or image of a particular location whereby you are trying to study some features or phenomenon and trying to assess the impact of a particular project. Maybe before the project comes on board, you must have acquired the satellite image of the location, and after the project has commenced or has been in existence for a number of years, probably after 10 years, you still have to get the satellite imagery of that location to actually study the impact of that project on that environment. So in the process of acquiring this information or data, it could be in a hard copy or in digital format, depending on what you want to extract from and how you want to extract this information from. So the transmission, reception, and processing of your data is very important in trying to obtain reliable information for environmental impact assessment. And another component that is very vital in remote sensing system is the interpretation and analysis of the information that has been received from our base station from the sensors that have been placed on the Earth, in the orbit of the Earth. So the processed image is interpreted visually and digitally or electronically to extract information about the target which was eliminated. So the information that has been received by the sensor, by your satellite imagery or your aerial photograph is being analyzed after it has been transmitted to the base station and further processing has taken place. The end user of this information now has to carry out further interpretation or analysis of this data. For instance, if you are trying to study the maybe in terms of the size of the river, how it has changed compared to when a particular developmental project has been sited within a particular location. Your knowledge of image interpretation, whereby you are trying to discern a river from a road, is very important. So those are one of the things you have to have a background knowledge and training on how to interpret imagery, because some of the imagery could be low resolution, as I'm going to look further, whereby the information are not really clear or discerning to the human eye. But your knowledge of image interpretation will actually help you to actually interpret and understand the information you are trying to extract from this data. And also the analysis that you will carry out also is very important, because which will actually depend on what information you are trying to extract from this data. So each information you are trying to extract from the data has its own analysis process whereby you have to carry out to extract this information from. So that is a very vital component of a remote sensing system, which you actually have to understand in order to apply this technology in the management of environmental impact for developmental projects. And also, the final component we are trying to look at is the application. Which area are this information actually applied in the process of trying to get accurate and reliable information from this remote sensing data. So the final element of remote sensing process is achieved when we apply the information we have been able to extract from the imagery about the target in order to better understand it, reveal some new information, or assist in solving a particular problem. For instance, in what is currently the trending thing now, that the disaster that we are actually aware of in the world, the wildfire in the Australia. This technology is very vital and could be used to actually study this natural impact of this natural phenomenon on the Earth's surface. So that is one of the ways of applying the information that you actually get from a remote sensing data in actually trying to study the impact of a disaster or a developmental project on the environment. For instance, you could actually acquire a satellite imagery, maybe considering the area of devastation of this wildfire, whereby humans cannot have the capability to drive through or go on foot to cover. Acquiring a satellite imagery of this location could actually give you an impression or the extent of damage, and trying to understand the impact of this disaster on maybe other natural phenomena like the forest cover, the water resources within the environment, and other natural phenomena in this area. That is this data or information could actually help you in trying to manage this impact on the environment. So those are one of the ways of applying your remote sensing technology in trying to solve some of the problems that we have on our environment. So apart from the components of remote sensing, also we are also going to look at the forms of remote sensing. Forms in the sense that what is the composition or what actually is the component of this sensor that is being used to carry out this study about the phenomenon or objects on the Earth's surface. And trying to look at the forms of remote sensing, we are trying to look at the types of sensors that is actually being used to study or try to derive information from the electromagnetic energy that has been reflected to these sensors. So remote sensing relies on measurement of electromagnetic energy, which takes several forms. As we have said earlier, we have a range of electromagnetic energy whereby they are made up of different wavelengths, and remote sensing relies on measurement of this electromagnetic energy, which from the type of sensor you actually use for your remote sensing system, different measurement at different wavelength could actually be measured from the radiation that has been transmitted to the sensor. So that is what the remote sensing actually rely on, the measurement of this electromagnetic energy by these sensors. And the type of sensor also determines what you actually information you can actually extract from the data you are trying to use for your studies. And also, the sun is the most important source of electromagnetic energy at the Earth's surface. We said this earlier. The general and the most important universal source of electromagnetic energy that is being utilized in a remote sensing system is the sun energy. And this actually takes the form of a different wavelength as it's being transmitted from the sun through the atmosphere and as it strikes on the object on the Earth's surface. So the reflection or the emittance of this radiation that is being measured from the sensor is actually what is really important, and it's what it forms the backbone of the data that we use for our remote sensing system. And also the sun energy is either reflected or it is either reflected as a visible wavelength, or it is absorbed and it could be re-emitted as it is for thermal infrared wavelength. So different objects or different phenomenon or processes actually takes place when the sun energy actually strikes on our object on the Earth surface where we are trying to carry out the study on. So some of them could be reflected back to the atmosphere. Some of them could be absorbed depending on the composition of the object that is being struck on, and some of them could be re-emitted. After absorption, they could now re-emit their own radiation. And the radiation they emit also have different wavelength, which is actually used in studying the phenomenon on the Earth's surface. So a remote sensing sensor is a device that measures and records electromagnetic energy. The different remote sensing systems, whether it is spaceborne or airborne, actually has its sensors, which is the device that actually measures or records electromagnetic energy. So what actually measures the electromagnetic energy within these sensors that within this remote sensing system, whether it's a satellite imagery, is the sensor. So the amount of energy that the sensor receives or the wavelength of the energy that the sensor receives will actually help you in trying to understand the phenomenon on the Earth surface that you're trying to study. So considering all of this about the sensor, remote sensing system could be classified as either a passive remote sensing or an active remote sensing, considering or depending on the sensor, depending on the source of energy that is being that these sensors actually used or is actually receives information, receive radiation from. So depending on the source of the energy and the type of sensor, you could actually classify a remote sensing system to be either passive or active remote sensing. So, like I said earlier, the forms or types of sensor that are attached to this remote sensing system could actually help us to classify the various forms of remote sensing that we can actually study in trying to apply this technology to environmental impact assessment. Also, so the first one is the passive remote sensing, and the passive remote sensing system, it measures energy that is naturally available. For instance, the energy from the sunlight, which is naturally available, whereby you don't have to try to provide this energy or this energy artificially. It is naturally available everywhere, depending on the duration or time of the day. So the passive remote sensing actually measures energy from this energy that are naturally available, and also it depends on an external source of energy, which is usually the sun. So without the sun, a passive remote sensing system cannot function in any way, and also it cannot be used at night to measure reflected energy. As we have said earlier, that this same system depends on the external source of energy, which is the sun, for it to actually work. But however, there are some systems that we could also classify as passive system, which can emit their own energy. Mark the word emit. Is different from what we call different from the other the reflection of energy. The reflection of energy actually depends on the sunlight, whereby the radiation from the sunlight is actually reflected from the object or phenomenon you are trying to study on the Earth's surface, whether it's vegetation or soil or water body, is reflected back to the sensor, whereby this radiation are actually measured and try to extract information from them. So that is one aspect of passive remote sensing, and the other one could be which that one actually depends on sunlight, but it could be another passive system remote sensing whereby information could actually be emitted from the object itself, and this could be used at night to actually study the phenomenon on the Earth's surface. So the passive remote sensing generally requires natural source of energy, and it depends on the sun. The active remote sensing, on the other hand, have their own source of energy for illumination. You are going to see the next slide is going. You are going to see the actual pictorial the description of our diagram, trying to really explain this further. So the active remote sensing emits a control beam of energy to the Earth's surface and measures the amount of energy reflected back to the sensor. So this system actually emits its own energy to the Earth's surface. And when this energy gets to the Earth's surface, the reflection of this energy from the object or phenomenon on the Earth's surface that is now sent back to the sensor is what is actually measured and could be used to extract any information about the object that has this energy has been reflected from. So that is how an active remote sensing system works. It actually emits its own energy. It's different from the passive remote sensing, whereby it depends on the sunlight, the reflection of the energy transmitted from the sun, which is sent back to the sensor. So another thing is that active remote sensing has the ability to obtain measurement anytime, regardless of the time of the day. So, for instance, if you want to actually extract information or actually get information from a location at night, active remote sensing system, for instance, for like example, your laser ray system and your radar system has the ability to emit their own light, and the reflection of this light, which is now sent back to the sensor, could actually be used to study the object that has reflected this light. So That is that, and the diagram, like I was trying to explain about the active and passive remote sensing. Looking at the diagram, and the first diagram on the top is trying to explain the passive remote sensing system. And in looking at the diagram now, the remote sensing sensor is actually depending on the sunlight, which emits the electromagnetic energy. And as this electromagnetic energy are being targeted on the object on the Earth surface, they are either reflected or re-emitted back, and it's being recorded by the sensor. So a passive remote sensing system cannot work without the sunlight. For instance, majorly all the Earth observation satellites that we use to carry out our studies about the phenomenon on the Earth surface, whether you are trying to look at the impact of a project on the Earth surface, must actually depend on the sunlight. If you're trying to acquire an imagery that was captured at night, you may not actually get any information from this object. So this imagery has to be image that has been reflected or has gone through a process of whereby the sunlight is part of it, and the reflection of the sunlight has sends the radiation back to the sensor, which we can actually use to now carry out our studies. And also the second diagram after the first one shows another form of passive remote sensing, whereby the object itself emits its own energy, unlike the first one that it actually depends on the reflection of the light from the sun. The object itself emits its own energy, which is sent to the sensor and recorded by the sensor. So the information that has been recorded by the sensor is now used now to study this phenomenon. Then the last image below depicts an active remote sensing, whereby the remote sensing sensor itself emits a radiation to the object on the Earth surface, and the reflection of this radiation that has emitted from this object that is now sent back to the sensor is actually forms the data that is now used to study the object that reflects the emission from the Earth surface. So those are the forms of remote sensing, and which we have to have the knowledge and background information about before we can actually know the different ways of applying this technology in environmental impact assessment, and also try to understand the sources of this remote sense data for our studies. So let's look at the types of remote sensing. There are several types of remote sensing, like I said earlier, based on the location of the remote sensing system or the sensor itself above the Earth surface. You could have the spaceborne and the airborne system, whereby the airborne is placed or is being carried by objects like your drone or your aircraft when they are actually carrying out aerial photography survey or trying to study phenomenon, whereby cameras are attached to this device attached to this system and used to capture information about the Earth surface. And your spaceborne, whereby you have satellite imagery, satellite system that are placed outside the Earth orbit, and information are actually received from the satellite from the different base stations and processed to actually extract information from them. So in terms of the types of remote sensing, we have the natural remote sensing, we have the camera remote sensing, and we have the satellite remote sensing. So the natural remote sensing is more or less like your eyes, because your eyes also serves as a form of remote sensing, whereby you are actually try to sense information from objects around our neighborhood without actually being in contact with this object. So the knowledge or the ability for you to discern various objects of different colors and nature or feature on the Earth surface forms what we call the natural remote sensing, using our natural objects like your or natural sense organs like your eyes. And also the camera remote sensing, which uses aerial photograph. They are the simplest and oldest sensors used for remote sensing of the Earth's surface. So before the arrival of the satellite imagery or satellite system, the oldest form of remote sensing was the camera remote sensing, whereby cameras were attached to aircraft and flown over certain region or locations to actually study information about this area, this phenomenon within this area. And the latest of it is the drone, which we could also attach camera and fly at different orbits and fly at different altitude above the Earth's surface to actually study phenomenon within the particular region we are trying to understudy. So this is the oldest form of remote sensing. And the aerial photograph is still in use despite the arrival of the satellite imagery, and it still have it forms the bedrock of some of the base data that I can actually use. For instance, you are trying to look at you are trying to get information about a particular area that has been that has gone through aerial photography for the past 30 years, whereby your satellite imagery satellite system were not in use then. The best source of data for you to actually carry out this study is your aerial photograph, which were actually captured within that location. So away from the camera remote sensing, we now have the satellite remote sensing, which is the latest form of remote sensing system that we have that we can actually use to obtain reliable information about objects or phenomenon from the Earth's surface. And this is a very important technology whereby you could actually use to capture different activities or features and that has taken place even before the activity or impact has taken place in a particular location. Probably you are trying to look at the impact of the project. The satellite remote sensing system has the ability for you to have various imagery at different points in time that you can actually compare and try to extract information from them. So those are the different types of remote sensing system that we should have an knowledge about before you could actually have try to apply this technology. So knowing about the satellite imagery, let's look at the various types of satellite imagery that are actually placed in on the Earth orbit. And these satellite systems belongs to several countries, and they serve different purposes, whereby they are being launched to the orbit and placed at various altitude on the Earth orbit and used to carry out observation and studies about phenomenon on the Earth surface. So this satellite imaging mostly are used for observation purposes and used to study the changes in the various phenomena that we have on the Earth surface. And the majority of them, the list is more than this, but for the sake of this training, I'm just listing a few of them. And the few of them that we have here is the Landsat. And this Landsat has maintained a continuous stream of data about the Earth since 1972. It was launched as far back as 1972, and is used to study several natural phenomenon that has taken place on the Earth surface. And it will interest you to know, I would like you to understand that this satellite system also have their peculiar features and information which they can actually give. So depending on what you are actually trying to study about phenomenon on the Earth surface, it will determine the type of satellite system that you can actually use. So different satellite systems have different resolutions, just like in your device, your digital device that you have, for instance, your phone. For you to actually, depending on what you want to use this phone for, there are several specifications that comes with each device, and this now inform what the kind of device you go for. So the kind of phenomenon they are trying to study on the Earth surface determine the data or the satellite you should actually go for in try to acquire your data for your um, environmental impact assessment. So we have the Landsat, we have the Nigerian satellite system, also which have the Niger Sat 1, Nigeria Sat 2, and Nigeria Sat X. And this was launched in 2003, while the Nigeria Sat X was launched in 2011. We have the Iconos, which is a high resolution imagery. We have the Spots, which is a French satellite system that was launched in 1986. The Indian Remote Sensing, which was launched in 1995, and the National Oceanic and Atmospheric Administration satellite system, which is actually used to study your meteorological information about the Earth's surface. So these are the various forms of satellite system that we have, and there are more of them there that are on the Earth orbit. So this is a typical diagram of satellite imagery of how it looks like, and considering the spatial resolution in terms of the size of the image you can actually discern from this satellite imagery will determine the type of satellite imagery you could go for. This shows a comparison between the Landsat imagery and Iconos imagery, and we could observe that in the Iconos imagery, the objects are actually more visible compared to the Landsat imagery. So the phenomenon you are trying to study, for instance, you are trying to study vegetation, would actually determine whereby you go for the Landsat imagery in trying to study this natural phenomenon instead of going for the Iconos, which is also more expensive compared to the Landsat imagery. So these are the characteristics of this satellite imagery that could actually determine the type of imagery you want to acquire for your study. Includes the spatial resolution, which refers to the size of the smallest possible feature that can be detected. And this detail discernible in an image is dependent on the spatial resolution. So we have two imagery that have been placed side by side. If you observe the imagery on the right, the features or the characters in features on this imagery are actually bigger compared to the imagery on the left. And this is a result of the different spatial resolution that we have that about some of the imagery satellite system that we have. So what you are trying to study about the phenomenon of the Earth's surface will actually determine the satellite imagery you actually go for, whereby the resolutions are different, and it will also help you to actually also acquire reliable information about this phenomenon. So another feature characteristic about the satellite system that you have to understand before you actually decide which of the satellite image you have to acquire for your study is the spectral resolution. And spectral resolution describes the ability of the sensor to define fine wavelength intervals. Before now, like I said earlier, I said that different objects on the Earth's surface have different wavelengths, whereby they reflect different wavelength and the electromagnetic spectrum, and the types of wavelength that is being reflected, that is being recorded by the sensor, will actually determine what you can capture from this object on the Earth surface. So the spectral resolution, in a nutshell, refers to the reflectance of some of the different reflectance and along the electromagnetic spectrum for the object that we have on the Earth surface. For instance, like I said earlier, that plants naturally they absorb all the wavelength on the electromagnetic spectrum and reflect infrared. So if you are trying to look at presence or absence of plants in a particular location, you could actually try to extract the infrared, and this will give you information about the plant cover or vegetation cover within that area. So spectral resolution is one thing you have to actually have information about before you actually decide the satellite system you should use. We also have the radiometric resolution. The radiometric resolution is of an image system describe the ability to discriminate very slight differences in images. So the final radiometric resolution of a sensor, the more sensitive it is to detecting small differences in reflected or emitted energy. So you have two satellite imagery on the left side of the right side of the slide, and if you look at the satellite imagery, there are differences in the reflectance of this of the object that has been sent to the sensor. So the radiometric resolution of the satellite system, which actually determine what information you could actually extract from this imagery. So another characteristic is the temporal resolution, which refers to the length of time it takes a satellite to complete one entire orbit. So different satellites revolve around the Earth and complete a cycle at different duration. Some could be in 1 week, some could be in 5 days, some could be in 12 weeks. So for the type of information you are trying to study, maybe the information you are trying to study is a phenomenon that has been happening frequently, maybe every two days, will determine the type of satellite system that you actually go for. And this has to do with the temporal resolution of the satellite system. And the temporal resolution is important in that it can help you to assess the persistent cloud cover, which is limited to a particular area. So considering that the cloud cover changes with the weather within a particular area, the temporal resolution of a satellite imagery, whereby the satellite system revolves around that particular location at different time, will actually be very important. Whereby if you acquire an imagery of a particular location that is not clear, you could actually search for that same imagery at another time. Also, the short-lived phenomenon, whereby you could also use to study environmental disasters like flood and oil slicks, which happens within a very short duration. So the temporal resolution is very important for you to actually decide which of the satellite system you should go for. So what are the applications of remote sensing? We are in the next training, we are going to look at in details the various ways whereby this technology is being applied in the management of the environment, and the few of them that I've listed here include a resource inventory, trying to carry out inventory of resources within an area, habitat assessment, what is the quality of the habitat within an area, the vegetation and forest cover change detection, how has the forest cover changed with time. Remote sensing system can actually help you in carrying out that study, and it can be applied in that area also. So also another area of application is environmental monitoring and assessment, wildlife tracking, and also in agriculture. So those are the various areas of application of remote sensing. And what are the benefits of using this technology is that it covers a large and inaccessible area that you could not cover naturally as human. By acquiring a satellite imagery or a remote sense data of an area, you could actually cover a wide area and study information about a wider area than you could actually study by going on foot. Also, it is fast and cost effective. So depending on the spectral, the quality of imagery you are going for, it could actually be cheaper and less stressful and cost effective than you actually going on foot to actually collect this data. And in data and information can easily be searched, analyzed, and presented. So you can actually from the data could be very easily acquired and analyzed and present for analysis or to use to communicate any information you're trying to communicate. And also it's easy to update information to be updated frequently, as I mentioned about the temporal resolution. So different satellites at different times could be acquired for different studies, and the data can be shared and exchanged freely. And also, reliable information can also be extracted for proper decision making. So thank you for listening to this training. Hope you've learned something from this particular topic. Thank you very much.